Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome to Abstract Online Support Program. This is Shabnam Fatima from APS Cherikas. I'm your mathematics teacher and it's your 9th week. Textbook, New Secondary Mathematics 2. Page numbers, textbook page number 72-76. Chapter number 3, Sets. Lesson, topic, Venn diagram, universal set and complement of a set, subset and proper subsets. Resources required, textbook, laptop, internet, Microsoft PowerPoint. Introduction. This lesson is about sets. Students will know about Venn diagrams, universal set and complement of a set, subset and proper subset. Let's start. Previous knowledge. How many ways to describe a set? Question number 2. This denotes. What is mean by this? You have to write in this blank. Question number 3. Describe a set in words. You have to describe this set in words. Question number 4. This symbol denotes. What is mean by this symbol? Write in this blank. Question number 5. You have given a set. And you have to tell, we read this as. We read this as. You have to write in the blank. Is a positive even integer less than 10? In this lecture, we will learn about universal set and complement or complementary set. First, we will discuss universal set. A set from which elements can be chosen to form a particular set is called universal set. It is denoted by Greek letter psi. Let's suppose we have a set A. Set of months, you have summer holidays. Set A actually be June, July. In 2 months we have summer holidays. Now the universal set is denoted by this symbol psi. The universal set must be the set of months of the year. So the universal set is January, February, March, and so on, December. This is the set of months. And set A is chosen from the universal set. If you belong to another country, the months you have summer holidays may be varies according to this set, and we will choose the months from the universal set. The main set is the universal set. So we will take another example. Example number 2. We have the universal set. In this set, we have set of natural numbers. Natural numbers are starting from 1, 10, and so on. Now we have a set B, numbers, set of even numbers. Even numbers are divisible by 2. So in universal set, we have even numbers 2, 4, 6, 8, and so on. So set B is chosen from the universal set. B is also a subset of universal set. Next, one more example. We have a set C, set of odd numbers. In universal set, we have also odd numbers 1, 3, 5, 7, 9, and so on. So set C is a subset of universal set. So both sets were chosen from the universal set. And both sets are the subset of universal set. I hope you understand this, right? Next, complement of a set. Here is the definition of complement of a set. Complement of a set of elements in the universal set other than the given set. as we were discussing about the summer holidays, the universal set was January, February, March, April, May, June, July, August, September, October, November, and December. And set A, June, July, set of summer holidays. Clear? Now, what is the complement of A? We write complement of A as A dash or A prime. We can also write universal set minus A. So, how to find the complement of A? The number of months are not present in set A. As you can see, in set A we have only 2 months, June and July. And in set A we don't have the other months like January, February, March, April, May, August, September, October, November, December are not present in set A. We write this month in prime of A prime set. Complementary of set is the months we don't have holidays. In this set, you can see that we don't have June, July. One easy way, you will subtract the elements of set A from the universal set and write the sets are left in universal set. Set A is the A prime is the set of elements in universal but not in A. Clear? Again, A prime is the set of elements in universal set but not in A. You can see that in set A we don't have the months, yet we don't have holidays. So, complement of A prime is equals to January, February, March, April, May, August, September, October, November and December. Example number 2. In universal set, we have natural numbers from 1 to 10. And second set O, we have odd numbers. Now, complement of a set O is the elements are present in set O. Which elements are not present in O? It's 2, 4, 6, 8, 9 and 10. Here you can see that 2, 4, 6, 8 and 10 are not present in set O. So this is the complement of O and we read as O prime, O dash. Let's discuss Venn diagram. Diagrams make mathematics easier because they help us to see the whole situation in a glance. English mathematician John Venn began using diagrams to represent sets. His diagrams are now called Venn diagrams. In Venn diagrams, we have a large rectangular box. We use universal set. We write universal set in a large rectangular box. And the other set represented by a circle within the rectangular, and the universal set is denoted by this Greek letter psi. Clear? This is the rectangular box, shows the universal set. Clear? And the circle inside the rectangle shows the other sets. Okay? Venn diagram, let's take an example. Suppose we have a set of vowels and we could choose the universal set letters of alphabets. And now we have to draw a rectangular box and we have to place all the letters of alphabet somewhere within the rectangular box. This is a rectangular represented by psi, is a universal symbol. Next we have to place the letters of alphabets somewhere within the rectangular, and vowels set shown by this circle inside the rectangular. This is the set of V, vowels, and we represented this set by capital V. Next, let's take an example from your textbook, page number 71, worked example 4. In this example, it is given that universal set x such that x is an integer between 1 and 10 inclusive, and a is equals to x such that x is a perfect squares. Part first is list all the elements of universal set and of A in set notation. In part A, you have to write the elements of universal set and set A in set notation. Solution part 1 is universal set from 1 to 10 inclusive, and set A is the perfect square. 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, and 2 times 2 4, 3 times 3 9, and 4 square is equal to 16, but 16 is present in universal set, so we will take the elements in A from 1 to 9. Okay, next question number 2, draw a Venn diagram to represent the set universal and A. Now we draw a rectangular and shown by this. Now we will write the elements of universal set and the second set, other set shown by a circle. In circle we have 1, 4, 9 is represented by capital A. So hold all the numbers in a universal set and set A is a perfect square. Clear? Next question number 3. From the Venn diagram, list all the elements of A prime in set notation. A prime, complement of A. The elements are not present in set A. In circle, which elements are not present in set A? The elements are 2, 3, 5, 6, 7, 8 and 10. So the prime of A is 2, 3, 5, 6, 7, 8, 9, 8 and 10. Now question number 4. Describe the set A prime in words. In words, you can see this A prime 2, 3, 5, 6, 7, 8 and 10 are not the perfect square. 2 is not a perfect square, 3 is not a perfect square, 5 is not a perfect square. So all the elements are not a perfect square. So in words, A prime is a set of all integers between 1 and 10 inclusive which are not perfect square. Let's move to the next part. Question number 5. State the values of number of universal set and the number of set A and A prime. Now, number of elements in universal set is 10. Counting from 1 to 10, we have 10 elements in universal set. And number of elements in A. Number of elements in A, we have 1, 2, 3. Just 3 elements. Just count the elements, okay? In complement of A prime set, we have just 7 letters, elements. 1, 2, 3, 4, 5, 6, 7 elements. Now, question number 6. State the values of set A, B, set A, universal set and A prime. It's done, sorry. Question number 6 is number of elements A plus number of elements in A prime is equal to number of elements universal set. Why or why not? Let's see. Yes, since A and A prime contain all the elements of universal set. You can see this is set A and this is A prime. In both set we have all the elements that are present in universal set. Do not contain the same elements. A and A prime. We don't have the same elements in A and A prime. Elements are different and both the elements are present in universal set. So when we add A and prime A, we will get the universal set. Student task. Textbook page number 71, practice now 4, and similar questions from your textbook exercise 2B, page number 75, question number 1, 2, 3, 4 and 7 are similar to the worked example 4. Clear? Next, subset. What is a subset? Set A is a subset of set B if and only if elements of set A is also an element of set B, and we write A is a subset of B. This symbol means is a subset of or include or contain. Let's take an example. We have one more thing. The empty set or phi is a subset of every set. Next, take an example. We have set A 1, 2, 3 and set B 1, 2, 3, 4 and 5. Now you can see that the element of set A is include in set B 1, 2, 3. So A is a subset of B. A is a subset of B. Next, example number 2. We have a set A, different numbers 3, 5, 6, 7, 10, 8, 11, 12 and 13, and set B contains 5, 11, 13. Now here, elements of set B are present in set A. You can see here we have 5 and 11 and 13. Now in this example, B is a subset of A because elements of B is include in set A. All the elements of B is present in set A. So B is a subset of A. Clear? Now we will take an example of not a subset. Not a subset. We use this symbol to represent not a subset. Here we have elements of A 1, 2, 3 and set B we have 1, 2, 3, 4, 5. Now B is not a subset of A. B is not a subset of A. Clear? Venn diagram. For example 1, in example 1, we have a set B. Larger elements in set B is the main set as we will draw a circle, and next we write the elements of B within the circle 1, 2, 3, 4, 5. Now here 1, 2 and 3. 1, 2 and 3 is the element of set A, shown by a circle within the circle, small circle A. So A is a subset of B. Clear? Now example 2, Venn diagram. Try it by yourself. Next, proper subset. Set A is proper subset if and only if every element of set A is also in set B. And important thing is there exists at least one element in B that is not present in A. That is not present in A, and we write as A is a proper set of B. Let's take an example. Example number 1, we have a set of A, 1, 2, 3 is a subset of B, 1, 2, 3. In both sets, we have the same elements. It's also an equal set, but it's also a subset because elements of A is present in B and elements of B is present in A. So both the sets are subset but not a proper set. Clear? How? Let's see. Example number 2. In set A we have 1, 2, 3 elements and is a proper set of B. In set B we have 1, 2, 3, 4 because the element 4 is not in set A. Focus here, at least one element in B that is not in A. So here is 4 that is not present in set A. So A is a proper subset of B. Hence, A is a proper set of B. Student task. Textbook page number 75, work example 5 and similar questions from your exercise, question number 10, 12 and 13. I hope you understand well. So thank you for watching.